Hello. Hello, can you hear me? Online students?
Yes, Laushi.
Can you see the black clearly or not? Did you log in the Tencent app with your student ID?
Yeah.
The name?
ID. Oh, okay.
Yes. Yeah. It's
Okay.
easier, it's convenient to find the here. I'm not sure he's really
This is almost.
this is Alma, right?
Yeah.
And this is Norman.
Shitu. Yeah, he's here. Norman Abdul Ad. No, not yet.
You're not here, right? There you
Yeah.
you they
Ife. Bob. He's not coming. Open up noise. Yeah, she's here.
here the room lava.
Sakawat. No, lava.
Lava.
Yeah, Java.
Oh, lava, yeah.
Sakawat. He's here. Yeah, he's here.
Yeah,
He's here.
Mm.
Lillian. She's here. See, break time. By that time, they'll change everything.
Here,
Okay.
the online students.
Break time, they will change. They are changing by the time,
Okay.
so that we don't.
So our class is billing. The international students said they can't see the black clearly and can't hear me clearly. The next time I'll have this class internet. No. They can hear, but some students tell me they can't hear me clearly. I think that if I have this class online, I can't tell you very clearly because the next chapters we have some equations or I need to explain clearly on the black. Right? Yes. can hear me?
You can check also.
Yeah, because they said that they can't hear the black clearly.
We had all our classes like
That's this class, live class.
in the internet, you just PPT and they can send that for what they did.
I'm
The way you share this report, the same has been on.
Just share the PPT.
No, but it's okay, it's okay. Yeah, because it happened. So now we make sure that my cameras out. But
because they said there are some noise when I have the live class.
that's
Noise.
noise.
Yeah,
Noise.
yeah. Noise.
Which noise?
I don't know. They said they just have some noise, so they can't hear me clearly.
Yeah,
I think now no. Okay. Yeah.
yeah.
Okay, so is it all class feeling? The first thing I just to explain the homework. Okay, some students send me the homework, but actually the preferred series values I have already talked in the class.
Now she was supposed to send me the homework.
Some students send me the homework.
She didn't know. Are we supposed to send it?
Not all students. I actually the homework I already talked in the class, but I received some homework. There are some wrong, not correct. Okay, I will just quote again. I'm not sure. So like this, I already let you to write or to do the exercise in the class, but there are some wrong. Like this and this. Students online, can you hear me? The first,
This is your voice.
I don't know why in my voice.
That's okay.
Oh, this is my voice I got. It's a little clean. Yeah, it can work. Okay. The like this line R20 divides 3 series. And I don't know why this is a word, a value 3.6.3 and then the 5.6. I think this is not right. So it should be yes. Not this one. So I think some students just copy the homework. If you just copy the homework, don't send to me, okay? I think I received about 15 homework. 15, yes, 5, 1, 5. But some of them are like this one, the same.
Did you ask her to send it?
No, just the same. I don't know why. And also, this is 1,000, not 100. Because this is 215, and that is 1,000. I have already talked in the class, okay? And then this is the answer. So what is the series of preferred values? I think you can to find the results in the book, not like this one. I don't know what is this. It's so many words. Maybe you find the answers into word, into late. I don't know. I think it's the or it's called the preferred values. It's E3, E6. Maybe this is the electronic components. So maybe it doesn't used in the mechanical engineering or is not used in this in geometric tolerance and measurement technology. It's not used in this book. So this is not right. But okay, this is the homework. I received this homework. His is very right. So I just to share his homework with you, and what is the series of preferred values, and how to commemorate all the preferred values. This you can to clearly to, yeah, this is the right, but you can to clearly to explain the ratios and what is derived of series. I think is very right. Okay, this is the homework. And next we continue our interchangeability and technical measurement. And this class we have the chapter 2, the basic terms and the definitions. From these chapters, I think it's a little difficult. Oh, it's more difficult than the first chapter. Okay. But this class is a little not so difficult. We need to learn a lot of terms. A lot of terms. The first term is the a lot of the terms, the features. So this is a part. The future is a general terms applied to a physical portion or part, such as point, a line, or surface. So this is a part, just the sum of the features. So all of the kind of the features, like the sphere, the core, the plane, the cylinder, the center point, axis, generatrix, and point. So like the sphere and cone, so they give you a part. So you can I think it can touch the part, the touch in it. So like the sphere you can touch, and the cone, the plane, the cylinder. You know what it is. You can see it clearly. When you measure it, you get to touch it directly, right? So like the center point, you don't know how to touch it. Just like when you design a part, it is a base, right? So this is another feature that is a derived feature. So the point you can touch it, so it's in integral feature. So this is a part. So like another part, this is a design part, and this is the real part that is different, because the real part is just machine it and to make it. The previous.
Yeah. So what's the difference between the derived?
The director.
The derived and the integral.
The difference of the what?
The derived feature.
Oh, the derived feature and the integral feature, right? So I think the derived is you can to touch it.
Oh.
It's a derived, like the an integral feature. The derived feature is like you can touch it like the center point. That is a design. It's a design feature. When you design a apart. So that is a point, is like the so-called point. Yeah, that is the derived feature. Like the axis, this is the axis of the part. Can you touch it? No, right? So that is the derived feature. But when you design a cylinder, that is very important. This is the line, and you need to remember to write it or to draw it, right?
Yeah.
And then when you drawing a part, so this is the part you design. So it's very theoretically or this is very normal integral feature, right? This is A is normal. But when you make it, when you manufacture in the field, you get the part is like this one, not so strict or strictly strict, like a curve or surface, like this one. This is the real feature. You get the real feature. And this is the D. So the D is called exactly integral feature, and the E is called exactly derived feature. So this is your get part, the part you get, right? It's not your design. And this is the D. This is associated part. So because this is not curve, not so curve, not so straight, it's a curve line. So and then you design you write a line in here. So this is a association line. So this is associated feature, right? I think I can explain clearly. So this lines like that take you the part design is not real the part you get or you make, because there's some errors when you make the part. And then a tone of shaft and hole. This is very important because you can see everywhere in the machine, in the parts. This example, this is a shaft, and this is a gear, a shaft sleeve, and a bell. This is a key slot. This is a key. So all the machine consists of different work pieces, because this is a part he can't work alone. It just to contain them together and they can to work together. So when this is a part and another part, they can to assemble together. So they should to fit together to ensure the machine work according to the predetermined. So like this part, the gear is to rotate with the shaft, right? So the gear should fit with the shaft, right? So how do they fit? According to the predetermined, just we need to design. And from the fit points, the part fit together can look at two faces. It's like this sleeve. The sleeve face is to assemble the shaft, this outside face. So we just study the two faces. How do they fit? And we use shaft and hole to present the two faces fit together. Like the gear is to fit the shaft together, and they can to rotate together, rotate quickly together. So we know this is the shaft, but the shaft term, the shaft term have different meanings, definition. The reference the external feature of the workpiece, the external feature of the workpiece, including which are not cylindrical. For example, the key workpiece. So the key workpiece is also called the shaft because it's very common. It's common in the machine workpiece, the workpiece. So the key included to the shaft. The hole that refer to the internal feature of the workpiece, including which are not cylindrical. So this is the hole, and this is the hole. The hole is and also the key snout is also called the hole. So when we learn some design, not the design, when the precision design, the principle is also suitable to the key or to the slot. So the shaft and the hole terms extend the relative standards of application range. They can be used to grooves, snouts. So you just to remember the grooves and snouts is also included to the shaft and include to the shaft and the hole. So that is very common. So one feature is shaft and one feature is hole. So just you may know what is the shaft and what is the hole. Yeah, so what is this? This is the yellow one.
Yellow one is association.
Is also shaft and also hole, right? Right. When you this is the real shaft. This is the shaft. This is a hole. Yes. But the yellow one, like the bell, this is a shaft because it should to fit with the hole, right? And also this is the hole. It should to fit with the shaft. So when we study this surface and this surface, this is a hole. This is a shaft. This is the hole. When we study this surface and this surface, is different. Okay. And another term is the size. You maybe you think that is very simple. It's the size. So, but in our this course is very important. It's important and it's basic. It is a size. So in the actually machinery, sometimes the feet is loose, right? It's loose. So the part can move relatively. Otherwise, the feet is tight to ensure they cannot move relatively. So what kind of this condition you need to have the loose condition, and sometimes you need to have the tight condition. So it's relative to the size, right? So the size is small, so it's tight. The size is bigger, so it's loose. So how do you to design the size? So the size of the shaft and the hole fit together determine the tightness. An end of expression the numerical value of the linear dimension. So just remember the unit is millimeter. So the size unit is millimeter. So when you learn the limit of the size, it is a U millimeter. This is mm. Okay. So and another term is actual size. So that is the size is basic size is the size you design. But the actual size is obtained by measurement. the actual local size we should. So could you tell me what is the like when you give your part, how many exercise? You know how many exercise? How many exercise? How many sessions of for this part? When you give your part, yes. Because this size is your measurement when you give your part. The different students just give a different size, right? So that is the actual size. It's like this one. This is a shaft. But when different students to measure the shaft, everyone get a size, right? That is the real. Not real size. This is the actual size. Yeah. It's not so for cylinder, the actual will be like at the figure like this one, and this is the shaft, and the hole is the same, right? But just remember we use DA is DA, capital D for the hole DA. Just remember in our discourse, like the capital word is always to show the whole, and the DA this is always to show the shaft. So when I give you all like this one, you know it shows the hole, and when I give you this one, you know this is the shaft, right? Okay. This is the nominal size. Nominal size. So this is the basic size. The parts fit together have the same size, like the hole and the shaft. If they want to fit together, have the same basic size. The basic size is always the same. And when you show the tightening and the loose, just the limit size is different. So the basic size is the round after calculations calculated from strength and stiffness according mechanics principle. How you know this material mechanical principle? Material mechanics principle. I think you have already learned, right? How to design a shaft. It's sophomore. When you are sophomore. When you are sophomore, you learn the material mechanical principles, and you also learned how to design a shaft with the strength and stiffness, and give some many equations to design. Yeah, equations to design a shaft, because you needed to calculate the stress and stiffness. So that size just the basic size you choose. Because this is an example. This the dimension. The dimension, the size you choose need to meet the force, right? So when you fabricate the actual beam, you may choose 20 for the diameter. So you can to bear more force. So for two workpiece surface fit together, they have the same basic size, right? This is the hole, the shaft. If they want to fit together, they have the same basic size. If this size is 550, and this size is also 550, so they can to fit together. Another term is limits of the size. So it's different. It's basic size. This is the limit of size. So because we learn that we cannot manufacture an exact size for workpiece size. So to ensure their functions, we have to give the size limit to combine the actual size and certain range for a qualified app standard surface. We define a term limit of size. So this means that that's the real size. That is the size you manufacture. That is not the same. So because you can to make or to manufacture an exact size. So I give you a limit of the size. If the size in this limit, that is the good quality. If not, that it will lead to not a good quality, right? So that is the limit size. And the two extreme permission of size of feature between the actual size to the line, the limit of size being included. The maximum limit of size, like this, one. The term we learned with the basic size, limit size, and TH, ES, the maximum limit of the size is the greatest one. Like this is the whole. You can just
Can you write and screen on the blackboard?
okay, screen, right? Okay, I can do all right. I just to tell you like this picture. Okay, so this is the whole. This is the basic size. This line. This line is the basic size. When you manufacture a whole, so this is the smallest one, and this is the maximum. The maximum is the greatest one. This is the maximum limit of the size. This line, and this line. This line is the minimum limit of the size, the whole. And for the shaft, so this is the maximum of the size, maximum limit of the size, and this is the minimum limit of the size. So, and also the D maximum and the D minimum for a hole is a capital, right? And the D maximum and the D minimum for shaft. When this is the DA, the DA is the actual size, right? When you measure the actual size, when the DA is the range is the D minimum and the D maximum, so that is okay. That is available, right? So the work or the part the workpiece you make is available, and this is the DA. This is for the shaft, yes. For the shaft, when the D minimum, the size you measure, so is you measure the D minimum and the D maximum is arranged in the DA. The DA is range of the D minimum and the D maximum. Yes, that is available, right? The deviation is the limit. It's also the limit of the size, like this one. So this is the deviation. It means this is the basic size. When the size you make, or when the size you manufacture is here, So it is okay. It is available. When the size, the whole size is in here in this range, it is available. So to simply the standard table, we usually use deviation to confine the size qualified. So deviation, the deviation, the algebraic difference value between a size and the corresponding basic size. So this is future. So algebraic difference value means that there are positive and negative for deviation. When the deviation is positive, we use the plus, cannot be omitted. For example, plus 0.025 or minus 0.012. The size minus basic size, like this one, this line for the whole, this is the basic size for the whole. So this is balance or plus. This is the base, yes, the plus, and this is also plus. This is the basic size. This is bigger than this one, right? So this is plus. For this, the shaft, this is basic size. So this is minus smaller than the basic size. So it's minus. It means the size or the diameter of the shaft you make is smaller than the diameter you design. So it's minus. So you cannot, the minus and the plus cannot be omitted. So size minus basic size, which sizes can be used to minus basic size? Can you tell me which size can be used to minus the basic size? And you can get the plus and the minus.
O for plus.
No. Which size can be used to minus the basic size? You can get the minus. It means that this is a basic size you design, and then a basic size, and then you need to design the limit. I can give you this logic of this size, okay? So this is design. Design is the rear, not the rear, is the theoretical size. Is the design from the mechanics principle, right? When you from the material mechanics principle, you get a diameter of the shaft, right? But this is the get a shaft. This is the design from the theoretical calculation. But for the manufacturer, the can to make like the real size. So you can give his a limit, like the limit, like this is 5. And then For the complement, the key to make is a real diameter. So like this is you can give this limit, like this one. So the size from like this is 5. And also the 50.02 is available, right? So for our course, for how to design, to design this, the limit of the size. Yeah, this is the limit of the size. And then when you get a part, this is a real part, you measure it. When this is the actual, you measure it, you can get a size. If the size is range here, so it's available, right? So that is logical. So for the deviation, deviation you get, so you get a size, your actual size, and then you minus the 50. So if is the get the plus or get the minus.
You want numbers.
Huh?
You want the number.
Wrong number.
You want the number. You want the name of the size.
Use the limit of the size.
I'm saying you want numerical values, but you want the names of the sizes.
You mean which size, right?
You ask which size.
Which size can use the to minus the base size, yes.
Ask you want us to give a value. You want us to give a name, a value.
Yes.
0.02.
0.2. Which size can 50? I think like this, I think is the basic size is 50, right? So that is the you measure the workpiece, you can get a size. That size to minus the basic size. And you can get a plus or the minus.
I don't really get your question. You just answer this question.
This is like to this picture of this slice is just give you how to distinguish the plus and the minus.
Oh. Okay, so the sizes that must be minus the basic size.
Yes.
The size smaller than the basic size.
Yes.
The size should be smaller than the basic size.
Is smaller is the plus, is bigger is plus, is smaller is minus. Yes. The real size you get. Yeah.
So actually that question is answered.
Question is actual size you get can be used to measure the basic size. Okay, continue. So it just this is this one. So the actual size and limit of the size. The actual size minus the basic size. The actual size you get to minus the basic size. So this is the actual deviation. Is EA. Is equals DA minus D for the whole. EA is this this EA is means that this is the TH, this is the tolerance you design, right? When you measure a workpiece, you get a minus or a plus or minus is EA. You can get a word number like 0.5, right? And this is for the first part, and the second part 0.006. If this is called also called the EA. The real you get from the measure, the real is DA minus D. So if this EA equals in this one. So it's also available, right?
So now, so wait, now so the actual one, the actual deviation
Actual deviation, yeah.
is the actual size. That's
Yeah.
the size you get when you measure. right?
Yeah.
Minus the basic size, the
Yeah.
size that you are supposed to have.
Yeah.
So which means if the actual size is bigger, you're going to get class.
Yes.
The actual size is bigger, you're going to get the class.
You mean that its actual size is the bigger than the basic size is the plus? Yes. If the actual size is smaller than the basic size is minus. Yeah. So, and the limit of the deviations. So the limit of the size minus the basic size, the up deviation. This is the limit of size, limit of the size minus the basic size. So the maximum limit size minus the basic size is the upper deviation. The low deviation, the minimum limit size minus the basic size. So for the whole this is the ES. And this is the ES. So this is the maximum limit of the size, right? So it's basic is minus the basic size. So it's the ES. And the EI. The EI is the minimum of the minimum limit size basic minus the basic size. For this one, the minimum is here. This is 0, right? The minimum. The minimum limit size, right? So if the minimum limit size is here, so we will give you the basic size is 15, but I need to make a lot of the shafts. His range is his dimension range is from 15 point like 50.005 to 50.01. So this is the EI, is the minimum. The minimum limit size. I mean, my purpose is that the minimum limit of the size also is bigger than the basic size. Sometimes. This is the design. Your design. This is the basic size you get from the calculation.
Upper deviation. One up and top.
Yes.
Lower deviation, one.
The low deviation is the minimum limit size. So for the whole, the ES equals D maximum minus basic size. EI is a lower deviation equals D minimum minus D.
If you have maybe maybe yes, distance 10.
It's 10.
Distance 10.
You can write the word.
The distance
Yeah,
10.
10.
But how can you be able to fix minimum and maximum?
This is the diameter of the hole of the shaft.
Diameter of the shaft.
Of the shaft, yeah. So how to remove the deviation and the, you mean that you design, how to design?
Yeah. So here, like, it's gonna be maybe 10.001.
Yeah.
That's the maximum. So here is 0. So 0.01 there.
Not sure. You mean this is 0. This is 10. 10 is the limit, or is the basic size, or is
Basic size.
the basic size. Why is it 0?
Because I wrote 10.0.
Yeah. Wrong question. So this is the basic size is 10, right? So this is his limit. So this is 0, 0, 1, this is 0. You like this one? This is 0, 0 and 0.01.
So if I want to get the upper division,
Upper division is 0.01. And the lower is 0.
this is no division.
Yes, deviation. It's not is me. Yes, this is upper deviation. This is the low deviation.
Okay.
And give some examples. Okay, how to calculate that. So for fit together the hole and shaft, the basic size are equal. The capital letter for hole. Then remember the capital letter for hole, the low letter for shaft. Yeah, the ES and ES, EI and EI is from the French. The equator superior and the equator inferior. We can remember an arrow. Just to remember how to remember that. The size is pass or fair. I remember I already talked to you that is pass or fail. The size is pass or fair. It means what the actual size is range in the minimal limit of the size to the maximum limit of the size. So it's pass. So it's available. Sorry.
Plus 40, right?
It's time for break? Okay.
Please, guys. The notes. The frame. But the notes. You these guys. That's because they asked them. So, but is it easy? If you let me show you that. Oh, and please don't please, it's break because of your noise. Guys, please, it's break, okay? Not you, please.
Yeah, so I'm going to give me.
Okay, continue. Back to our class. Okay, continue our class. We just talked about the size tolerance. The size is pass or fail.
It's pass when the DA for the whole, when the DA is less than or equal to the D meaning less than or equal to D max. Still, when it is greater than, when the D meaning is greater than or equal to D, or equal to the basic size, and greater than or equal to the maximum size. Is it clear?
Almost correct. That is the actual diameter. This is the actual diameter. The actual size is range in the minimum limit of the size to maximum limit of the size. So that is it's a pass. It means that the part is available, and this is for the hole. Yeah, this is for the shaft. The shaft is the same. So the EI and the EA is the actual tolerance, actual maximum, actual limit of the size. So this is the limit of the low limit size, low deviation. This is the low deviation. This is the up deviation. So the actual deviation is between the minimum to the maximum deviation. So it's plus. So for the whole, it's the same, right?
Yeah.
Okay. This is the size tolerance. So only the size tolerance. The permissible variation range of the qualified actual size. So it gives the difficulty degree of manufacturing. It also presents the procedure of the workpiece. So it means that so this is the workpiece. It is the procedure of the workpiece is the difficulty degree of the manufacturing. This is the basic size. The basic size in the tolerance. If the tolerance is like this one or like this one. So this is easier to manufacture, right? So this is hard to manufacture. So this is the tolerance is difficulties of degree of the manufacturing. So it is absolute the value of the difference between the maximum limit of size and the minimum limit of size. It's also when you design the tolerance, the size tolerance. And if the size is bigger or size is smaller, it's bigger or this is tolerance is bigger or tolerance is smaller, it means the difficulties of manufacturing. So the TH, H is for the tolerance, the H is for the hole, the T is the tolerance, the equals the maximum minus the minimum, and TS, the T tolerance S is the shaft, yeah, is the maximum minus the minimum. So it's absolute. So it's always the plus, right? Because this is this one. Is abstract. So this figure.
Absolute value.
Absolute value. Okay. So this is always is right? It's plus. Yeah, positive. So this is always is positive. So it's the tolerance. So it's also the author equals the up deviation minus the low deviation, right? So it's absolutely positive. So this is also is up deviation is minus low deviation. So stress and absolute value means the tolerance always is positive. It's not is level, it will be level 0. If it's a B0, is like this is the actual, the size, the part you make is equal the part you design. You can to manufacture it, right? It's real. Yeah. So huh? This one? You have some question? Okay. Do you have some question, online students? So if you have some question, online student, you just type to the consultant. Yeah. So this is how to write or to draw the feet. So use the tolerance though to graphical present the relationship between tolerance and the deviation, and it can present the relationship of phase between shaft and hole as well. So this is how to write all of the term we know, like the basic size, the up deviation, low deviation, and the tolerance. We just to write them on a picture, in a picture. So this is the 0 line. 0 line is the basic size, right? Let me see. So this is a plus, is up. So this is a minus, is here, is low. So this is the basic size. And this is for the whole. Whole is the tolerance. So this is up deviation, right? This is the low deviation. So, and this is the shaft. Shaft, this is his basic line. When the feet together, they have the same basic line, basic size. So this is the up deviation for the shaft. This is the low deviation for the shaft. And the unit is U millimeter. So this is the tolerance. This is shaft tolerance. So when we give some words or some values, you should how to know. You should know how to write or to draw this picture, and then you can to distinguish. This is the feet type. Okay, so this is the zero line, the present the basic line. Like I'm to draw on the. There are some examples. So the fundamental deviation is nearest to the 0 line. This is 0 line. This is low. We can look at it, the least one and the absolute value of the upper limit deviation and the lower limit deviation. You can understand the up. This is the up. This is the low. And this is the up. This is the low. The up deviation. This is low deviation. This is the shaft.
Actually, it fits when the shaft and the hole, there's no motion between them. If we should fit the shaft in the hole, it's like it's holes, as a fit,
Yes.
otherwise it's moving.
It's moving.
Ah.
Why is it moving?
If it's moving, is
If the moving is a clearance fit.
clearance?
Yes. So we can talk about this question after.
Okay.
We can get 6 terms from the tolerance zone for hole and shaft. So the 6 terms that we learned before slides. Okay, that is this is the basic size. And the 2 limits of the deviation is E up deviation, is low deviation, right?
Yeah.
And it's the size tolerance. This is the size tolerance. Is TH. TH is for the hole, right?
Yeah.
T is the shaft, right? And maximum limit of the size and the minimal, minimal limit of the size. And for our course, the basic size is always null because the basic size is you know from the calculation, from the material mechanics, right? So is from the first or something. You can calculate the stress and stiffness. You can get the basic size. And in our course, we always know. And if we know two of the other 5 terms, we can calculate out the left 3, right? Because the ES minus EI equals tolerance. This is up is low, so it's a tolerance, right? It's a maximum limit of the size minus the minimum limit of the size. It's also the tolerance, right? Yeah, I can give you some. So I summarize the relationship for the whole. You should summarize it for shaft. I think it's the same, right? So example, like this one. If the size, the basic size is 550, the whole, the maximum limit size is 50.025. The minimum limit size is 50. The diameter is 50. This is the hole, the shaft. The maximum limit size is 49.975. The minimum limit size is 49.959. So drawing out the tolerance those figure.
Draw.
Yes, draw the figure like this one.
Okay.
Like this one. Just how to remember, just let you to remember the 6 terms. Because after the courses, we should to use the 6 tolerance. Okay. You should to know to write or to calculate. It's very simple. The D maximum, D minimum, and ES, EI, TH for the whole. And the shaft is the same, D maximum, D minimum, ES, EITS, yes. And to draw a figure, the tolerance zone figure. The students online? Hello?
Yes, 老师。
Yeah, could you join out the tolerance zone figure and type and take a picture, take a photo to the link to the textlet. Textlet to here, capture here.
How is the figure in data? Yes,
Here.
Yeah.
Okay, I can to figure in the basic not.
These two values should be same, right?
Yes,
Should be same.
the same. What do you mean the same? You remember? Is because they have the numbers here. It's not like this. This is you mean that this is not like this one. Plus this is a baby here. Because there is your question.
Say this TH and TS.
TS
It should be same.
the same.
It should be same or different.
Same with what?
It's
Same TH.
Yeah.
No, not the same. Not to the same because there are some words in the values in the example. Okay, you have already finished it. Okay, so we can give you the question. So the ES, right? This is for the shaft. It equals D maximum minus D, right? So it's plus 0.0 25 millimeter, or is the U millimeter? It's always the same, the right. So EI is up, is low deviation, right? Is the minimum equals D, so equals 0, right? So is ES is the maximum minus D, so is minus, right? Minus 0.025 is minus 25 UM, and EI is the minimum minus D, right? Is minus 0.041. So when we draw the picture, the figure, so this is the basic line, okay? It's 0. This is plus, this is minus. So this is the basic line. So it's 15 millimeter, right? This is the basic size. So this is 0. 0 is EI. This is ES. This is 0. This is 25, right? So this is tolerance. So this is for the shaft. So this is upper deviation, is low deviation. So the unit is UM. So and for the GB about mechanical drawing, if the length unit is mm, so if this is minus 0.041, so the mm is not be read out. You cannot to write the unit if this word is like the mm, and to this case use UM for deviation, so the unit should be pointed out. But if the unit is mm, it cannot be, it needn't be read out. Okay? You have some question for this example? Online students, do you have some question for this example?
Lost there micro m means sorry, mu m means micro m, right? Micromillimeter, right?
Just again.
Mu m means micromillimeter. Am I wrong or am I right?
So U millimeter. So if
Yes.
he write
Does it mean micromillimeter?
It's right, yes.
Okay, Lost.
Micro millimeter is micrometer. Micro is
Meter.
one.
I'm
It's
still wobbly.
Six. No, this is very complex. December is micro. It's micro. Mm. Millimeter.
This is millimeters.
Yeah.
This is the unit.
Yes.
This is 10⁻⁶ meters.
Yes.
Yes, that's what I'm asking.
Okay. Yes. Yes. 6. Oh. He asked that 1 UM equals how much the M, right?
Yeah.
Okay. It's 10 minus 6. This is not our first content, okay? Do you have some question? Okay, continue. So, can you write? Can you do 1, 2, 101 or 2, and then the left is for the homework. And that you just to write, do the exercise for the whole, the first 9 the first line, the second line, the first line and the second line, and the third line and the fourth line for the homework. Also, if you write very quickly, and you can write all of that, because I think it's very simple.
Also, can you do the first one? Not sure.
I can give you 10.
Actually,
Oh,
I will do the first one together. So we see how it is then.
the first one together. Just to how to do it, just to write the right number on the call, on the color, on the line. So I can explain the answer questions. To fill up the following table, the unit is millimeter. Okay. So the basic line is the whole for the whole is 10 millimeter. The symbol like the maximum limit of the size. Like this one is maximum limit is whole for the D maximum, right?
So 0.014. 0.4. 0.04.
Yeah, 0.04, yes. So the minimum, the D minimum, right? The symbol is D minimum, right? So is the 10.025. So the up deviation is ES.
Yes.
Yeah, ES. So the value is
0.015.
the up deviation is 0.
It's 0.04.
Yes.
Yeah.
Yes. The ES equals the maximum minus D, right? So is 0.04. So this is the low deviation is E. Yes, EI. Yes. That is 0.025. So the side tolerance is
TH.
yes, TH. The value is ES minus EI. So when you draw a figure, like the tolerance figure, the zone figure is very simple. I can give you 10 minutes. 10 minutes to write the second line. Okay.
Thank you.
And then draw a figure. The tolerance zone figure. Here. Okay.
supposed to give out.
You ask some question?
It's supposed to give out.
Yes.
You don't know.
You don't know how it works? Officer.
Give out the book there.
This is the reference. This is our book we use.
As it is, we buy ourselves. Are they supposed to give it to us?
I don't know. You can ask the officer. I buy it by myself.
What's the symbol for our deviation?
Still on the deviation. Still on what? Deviation. After deviation. For the shot. Yes. Yes.
Yeah.
This is the not the caps. Not the caps.
This is my you.
Yeah, this is the one. Yeah, that's nice. Right. Yes. Yes. Okay, I will give you the answer, okay? Please. Oh. Yeah, this is right. To write the figure.
What's all of them?
Just one, two, three.
Okay.
This is for the. There is down here, there is. Okay, I think we use some very simpler method how to calculate that. Okay, it's not like to. Back to see. For the shaft, the second one. Okay, so this is the baseline, right?
Yeah.
And this is the zero plus minus. When you to draw the figure, you can to calculate all of the values very quickly. So this is the basic line or basic size is 14, right? It's 5.
What's
40. This is
our
the first is simple.
Okay, yeah, second.
The second one. So this is the zero because you give this and this value minus 0.006, right? The minus is here. This is it's plus. The minus is here. So this is the up is E S, right? So this is the minus 0.060, right? This is the millimeter. So this is the up. The shaft is up. Up derivation. This is the shaft, right?
Yeah.
So this is the ES, right?
Yeah.
So what is the tolerance? Tolerance is what?
ES minus EI.
Yeah, that's the value.
The value to gonna
Here, this value is here, right? Is TS.
put yes, yes.
TS 0.046. So and this length is 0.06, right? So this is what?
This is 0.106.
So this
Minus 0.1. Minus
0.
1 no 0.106.
106. So how to calculate this one because this is minus 0.06. So the length is 0.46, right? So this is E I, right?
Yes.
So the TS equals ES minus EI. So this is not the capital, okay? Like this one. ES is minus 0.060. So minus EI equals 0.046. So you can use this equals to calculate this one, right?
Yeah.
Right?
Yes.
So when you to the maximum limit of size in this one. So this word is this one. This is the 14, right?
Yeah.
So this is this word so is 69.94, right? Because this is minus 0.06. So this the size is here, right? The maximum size, the maximum, right? But this you can't write this. You can. So this is the tolerance, the tolerance no figure. Like this one, tolerance no figure. This is the shaft. So this one is 96. This is the maximum deviation, maximum limit of the size. So this is 60 is 40 minus 0.106, right? Is 0.
That's 8.89.
40
That's
8.94. So this is
Yeah.
the minimum of the limit of the size.
Yeah, that's 8.89.
Here you have some question about how to write this, or how to calculate the values? So the symbol, this is the D maximum. This is the D maximum. This is the D minimum. D minimum is this, okay? D minimum, D maximum. So this is 39.94.
Yeah.
So this is 39.6894. That is the TS. Do you understand it? Electric. Did you have some questions, online student? Trying to see the black clearly. Yeah. Okay, we just see the black clearly, right?
Sure.
Okay, hello.
Is there any tolerance?
Okay.
Types of learning?
Coloring.
Yeah.
Coloring. Not the type. And the feet have some types. And the clearance feet. And the translation feet. And it's theory feet. And I will talk about the later topic. The topic. Relax. Your emotional that relax. I think also from election tolerance. This is the that actually this is the beloved but I just to draw half. It's like this is the basic size. This is the basic size is a half, basic size is the line. This is the zero, is the half of that. Let me see, no. He asked, that means the bilateral tolerance is not. I think it is. Bilateral tolerance. Let me see, it's the, no, it's the bilateral. You cannot to check. To check or to find from the table or from the ISO standards. Tolerance. It can't have, no, not this one, we learned that. we can learn from later class. Later class, we want to find the intelligence. You mean the word. This is a standard tolerance. If it added that if this the base size is 14, the base size is 14, and then tolerance is a standard value, not like the p size like 0.06. It's a standard value, and when you find from the table is standard the table. Have a place to learn how to find the table. So we learn this figure that you understand the color, and then at least understand what the type of the feet you get. And this okay, and this is the same. It's the same, and you can do it as the homework. Okay, the answer.
We need to send you on email. No need to send.
I mean this one here. You just to write in the table, write in the letter, and give to me. Maybe online student just send to my email.
Okay.
Just to write the letter, and take it in the later class.
You have to draw the figure.
Yes, draw the figure. Okay, 1, 2, 3, 4, 5. This is the same. We are used to draw the side towards the diagram, the figure. Okay, the next we can learn this another term is the feet. This is it's more difficult than this one. Okay. When this we just learned a shaft and a hole, that is a finger, and then we learned them together. So the feet, how the hole and the shaft can fit together.
Fundamental derivation.
Huh?
What is fundamental derivation?
What to find of the
Fundamental derivation.
fundamental?
Fundamental.
The fundamental.
Yeah, fundamental derivation.
Yes.
What
With the fundamental term
derivation?
variation,
Fundamental deviation.
deviation.
Yeah, like ES, EI, but not ES, but the one just minimum and maximum deviation. As asking fundamental deviation.
Back. To find the fundamental deviation.
Yeah, this exercise.
You mean this one?
Fundamental derivation.
Oh, this is what is the fundamental deviations? That's the upper, the upper and the low deviation.
Both of them together are deviation.
The up and the low is the fundamental deviation. This is just the 6, the 5, the 5 terms like the ES. Okay, the ES, EI, D max, D minimum, and the tolerance, the 5 terms. Okay.
Yeah. So
the fit, and then we know the fit. The relationship results from the differences in value between the size of the features, the hole and the shaft, which are to be assumed. So it refers to a batch of the workpiece before assembly, not for a certain pair of hole and shaft. it means that there are so many parts or so many holes and so many shafts that need to shift, that need to assemble together. What kind of the feet? What kind of the feet the lead? So if this is the shaft is here and the whole tolerance is here. So this is the clearance. When the shaft is here, the shaft is here. This is the tolerance is here. It means that this is the low, right? This is the low deviation. It's the minimum. It's the maximum. This is the minimum. It's the maximum. So there are some shafts and some holes. You choose someone. So some are the clearance and some are the interference. Then another like this one. So the peak tolerance is up in the hole. So we learned these three types of the symbol of feet. Okay, the first. I don't think I can explain it very clearly. Okay, I can explain it again. Can you understand me?
Yes.
Okay. So like a manufacturer to produce a lot, so a batch of the workpieces. So if he needed to move it very quickly, like they can the hole and the jaw can assemble together. They can move it very quickly. So he needs clearance here, and he can a little clearance here. He can to move it very quickly, and then he can get a part, get a shaft and get a hole assembled together. Yeah, it can move it very quickly. So it's okay, it's available, and then he get a part and get a hole. It's assembled very tightly. He can't to remove it very quickly. No, it's failed, right?
Yeah.
So how he can make sure this a batch of the workpiece can to follow that pair it very rotationally or either to assemble it very quickly. So it means that all of the parts and all of the shaft and all of the hole want to assemble it, and they can also have some clearance.
Yeah.
Understand me? So how we can to make sure a batch of the workpiece to assemble it and have some clearance. That is the clearance fit.
Oh, so when the goods are single,
Yeah, assemble it.
we can move. That's the clearance.
Yes.
We can't move. That is. We can't. If they are fixed. That's what
They can't move.
Yeah, it can't move. Is the interference.
interference. And they are we can move. That's clearance. That's not true.
I mean, why we need to design the clearance and the interference and the transmit fit, because we need to design a lot of the fit or a lot of the parts.
Okay, that's not. Therefore, that's the for the clearance. Clearance. Those-
Yeah,
For the clearance.
yeah.
So different purposes, different bachelor. One the one is to think, then we need to do for clearance. We make a batch of purposes that can fit both our possible.
Yeah. So that we learned all of this mean that this part is interchangeability. Okay, once we learn the terms, okay, continue. The clearance, the positive difference between the size of the hole and the shaft. That means the hole size is larger than the shaft. Use X to represent it. So it means the clearance. It means this shaft and the hole. There are some. The hole is large. The shaft is always large. The shaft size. It means that there are a lot of the parts, a lot of the shaft, and a lot of the hole. And I get a hole and I get a shaft. They have a symbol. Yeah, they have a clearance. So this is a clearance. And I get a larger hole. I get a larger shaft. The hole is large. The shaft. The all of the hole is larger than all of the shaft. So this is a clearance. Get that? Okay. And the interference, the negative difference between the size of the hole and the shaft. That means the hole size is smaller than the shaft size. Use Y to represent it. It means that this is a hole, this is the shaft. There's a lot of hole, there's not a shaft. And get a hole, get a shaft. They can do a symbol. And the hole is smaller than the shaft. So that is interference for a lot of the parts. And another one, always the whole size minus the shaft size, then to look at it is positive or negative. Like this one, this is a clearance, this is a interference. This is all of the shaft is larger than the hole. This is interference.
What is clear tolerance?
Why?
What is tolerance?
What is tolerance? What is tolerance? So for the clearance, this is the tolerance. This is the tolerance. Why? What?
What is the definition?
Huh?
Definition. You want to know what is the tolerance?
What is the tolerance?
This part should be tolerance or not?
Oh, you mean the part tolerance?
No. Tolerance. What is tolerance here?
What tolerance is like this is an example. Yeah.
What is tolerance here?
The tolerance is always is here. This is a rear. You I mean the tolerance is means a lot of the part we design or how design a tolerance. There are some mix. Okay, let me negotiate it. That's okay. This is tolerance, right? The tolerance is means a lot of the parts, a batch of the parts they have the tolerance. If this is a part and a one, that is a one hole and one shaft, there's no tolerance. It means it's the real part. If this real part, this part, the size, the actual size is between the maximum and the minimum, that is past, that is available. Yeah, and the tolerance is mean that you design a tolerance, and then the manufacturer to make the parts or the shaft or the hole. All of the when you marry you make it and you measure it the actual hole actual size is between the tolerance that is passed, that is available. Do you remember me?
You can't figure out tolerance in figure. No, but you can calculate it.
No, you can't. If this is the whole. The one that is so the shaft remain. There's a range of value it should be in. It's not within that range of value, it's not. So that range of value above the actual value of the product.
So that means like you can figure out.
I got you.
You can figure out.
You can't
You can, but you can't say unless it's done manufacturing.
This we need the tolerance is that if this is the tolerance, so one of the hole, one of the shafts is here, is here, is here, is here, is here, the shaft side, lot of the shaft side. Right? So this is the hole. The hole is here. So one of the shafts is can be assembled with the hole. They can have the clearance.
Yeah.
This is the basic. So this is the hole. So this is the shaft. Okay. So all of the size of the hole is bigger than all of the shaft of the hole. The shaft of the size.
Yeah.
The clearance. Got? And this one, all of the shaft, the size is bigger than the hole. That is the interference fit. So there's a lot of the part of the shaft, there's a lot of the part in the hole. When you get a shaft, get a hole, someone is clearance and someone is interference. That is called transition fit. Got that? Because our course is interchangeability, so you can you get it, you can change it. So we remember the tolerance, the positive relationship of the hole and the shaft, then we can grasp the 3 fit classes. So there are 2 parameters, linked clearance or interference, to describe every fit class. Okay. Okay, I think this is a little difficult for this one. From a batch of the workpiece, because we study a batch of the workpiece, a lot of the workpiece. So any hole and any shaft fit together, there is always clearance. So that means the size of any hole is larger than the size of any shaft. So the maximum shaft, the maximum hole minus the minimum the shaft is a maximum clearance. From this one is the maximum hole, right? Is here, the hole diameter, and minus the minimum shaft. So is the maximum clearance. It means there's a lot of the hole, there's a lot of the shaft. You get the maximum, it means the maximum diameter, and to assemble the minimum shaft. That is the maximum clearance. They have the maximum clearance. Got?
Yeah.
A break?
That's the job.
Okay, do you finish this point? So it's also ES minus EI. It means that the maximum equals the minimum. The minimum, the up deviation minus the low deviation of the shaft. This is the hole.
So the maximum deviation of the
Hole minus the yes.
shaft.
Yes. Because the maximum, I understand the maximum of the hole to assemble the minimum of the shaft, they can get a maximum clearance, right?
Yes.
The minimum clearance is mean that you need the minimum hole to assemble the maximum shaft. You can get the minimum clearance, right?
So maximum clearance
Then
It's a very large clearance, large clearance.
oh yeah.
And then is a minimal clearance. Okay,
Yes.
get the term. So when you figure the tolerance low figure, you like this one. This is the up deviation. This is the low deviation. You can get the maximum clearance, and then you can use the minimal hole minus the maximum shaft. You can get the minimal clearance. Okay. The variation of the clearance, the variation, it means that from the maximum to the minimum, right? Maximum clearance to the minimal clearance.
Which means both tolerance, right?
Huh?
The tolerance with the
Tolerance.
tolerance with the shaft are together. Yeah.
You mean what is the tolerance? Is the tolerance of the hole and tolerance of the shaft?
Are together.
Yes. I can give your term is that this is a lot of the part, a lot of the shaft, a lot of the hole, and then they have the tolerance.
Yeah.
For the one, don't have. For the one shaft and one hole, he has an extra size, right? So the extra size is between the tolerance is passed. Because we can design a lot of the parts. This part is interchangeability.
So variation clearance is the tolerance of the fit. Variation clearance.
Variation clearance is made the tolerance, the clearance from the maximum to the minimum.
I understand, but my question is, so you have a shaft. You have a shaft. The shaft can have tolerance here, tolerance.
Yes,
tolerance here.
yes.
Now you have a fit. You have this. Supposed to join. This is the shaft.
Yeah,
This is the hole.
yeah.
So variation of the clearance is the tolerance of the whole pit.
Yeah. Yeah, this is the wall of the tolerance, right? It's here. Yeah. Interference fit is the same. Doesn't mean that the shaft is the size of the shaft is bigger than the hole, so that interference. So from a batch of worksheet, any hole and any shaft is fitted together. There is always interference. That means the size of any hole is smaller than the size of any shaft. So the maximal interference, the minimal hole minus the maximal shaft. It means that you get a minimum hole to assemble the maximal shaft. You can give the maximal interference, right?
Yeah, that's it.
The minimum hole to assemble the maximal shaft. You can get the maximal interference.
So the opposite of clearance.
Opposite the clearance. Not the opposite the clearance. Is understand
Okay.
understand later, okay? And the minimal interference or the maximum hole minus the minimal shaft, so they can get the minimal interference. Okay, or later like this figure. This is a shaft because this interference and the shaft is bigger than the hole, right? So this is the up deviation is the maximal shaft. You can assemble the maximal hole, so you can get the maximal interference. This is the minimal hole. This line is the minimal hole. The size is the minimal hole. When you get the minimal shaft to assemble the maximal hole, you can get the minimal interference.
What is this? Capital A and small d.
Capital this one? Capital what?
Small d is for the whole.
Huh?
Small d is for the shaft. Plus,
No way, you.
capital D for the whole. Small, actually, capital D for the whole.
Huh?
Small d for the shaft.
什么？Sorry，
Capital D is for the whole.
好啥？好
Capital D.
它是
Capital D is for the whole.
啊
Capital D, big D.
big D。哦，这 you mean the D？
Yeah.
这 D is for the whole。
Yes.
啊
And the smaller portion.
，smaller the shaft. Yes. Here is I already said that before. What the capital is for the whole, the smaller is for the shaft. All of that, like this EI is for the whole. The ES is for the shaft. Yeah. So the variation of interference is T1 equals maximal interference minus minimal interference equals the tolerance of the shaft and the hole. The transition fit from a batch of the workpiece. Any hole and any shaft fit together. There may be clearance and interference. Back. Any hole and any shaft fit together. There may be clearance or interference. The maximal clearance, the maximal hole minus the minimal shaft, that is the clearance.
Plus, the difference between transition clearance and what?
What is the difference of the transition fit
Clearance.
and the clearance fit? The transition fit, because there may be clearance or interference. Yeah, because you mean that a lot of the workpiece.
Can you give an example of the transition?
Example of the transition fit. So this is, but maybe this is a you mean example of the properties or the field of what?
Actually, you have this, that's clearance.
Yeah,
You have this.
Yeah. transition. But interference. Yeah.
What's the transition?
Okay. You mean the example, okay? That is a one example.
Yes.
When you product a lot of the workpiece.
Yeah, some part is clearance, some part is.
Yes, because
Together is transmission then.
I explained this to the husband, to him, because this tolerance is exists in the a batch of the workpiece.
Oh.
With that, because this from the batch of the workpiece, that there exists a tolerance.
Yeah.
And when you get a one part, its actual size is range in the tolerance that is passed. It is available, it's passed. When it is not in the tolerance, it's a failure. So the tolerance is means that a lot of the batch of the workpiece.
Just only with the batch.
Yes. So for the transmission, that you product a lot of the part of piece, and you get one. Someone is transmission, and someone is clearance, and someone is interference. That is transmission. It means that the tolerance they have some cross. Mean that this they have some cross. Got? So the maximum clearance is means the maximum hole to minus the minimal shaft to get a clearance, right? And the minimum interference, it means the minimal hole minus the maximum shaft. They have the interference. Or the variation is also the tolerance of the hole plus the tolerance of the shaft. Okay. A pair of the hole and the shaft. The basic size is 15. The up deviation is 0.025. The low deviation for the hole is plus 0.012. For the shaft, the up deviation is plus 0.015. The no deviation is minus 0.018. So to calculate the maximum limit size, the minimum limit size, right? The maximum limit size and the minimum limit size, I think you can to calculate it very correctly. The limit clearance or interference used to distinguish what type of the fit, a variation of the fit, and drawing out the tolerance zone. What class fit is. So, I mean, you need to figure the tolerance like this one.
Yeah. One kind of tolerance.
You will have to give you a break, okay, and to think about this patient. Think about the patient.
Hello. You don't need to go in your break. Guys, break, huh?
back to our class. I'll give you the how to calculate the answers. So for the shaft and the hole, they have the same basic size, right? So the hole ES is minus, or not is plus 0.025. So this is 50. So is plus is here, right?
Yes.
Right? So this is like this one. This is ES is 0.025, right? So what is the up the low or the up the low deviation is 0.012. Is here. It's always is up the zero. Oh, sorry, this zero is you need to remember to write this. This is the here. It's 0.112. Right? This is current. Right? Current. This is E I. So it's captured. So this is the whole, right?
Yeah.
So the shaft is, I think I write a little big. Yeah. It is here. ES. Right? So this is for the shaft. The up deviation is 0.050. So it's here, right? But this is zero, right? It's here. So it's here, right?
Yeah.
And this is 12. So it's up, right? And the EI is 0.018. It's here, right? Right?
Yeah.
It's here. So this is I, this is E, S. So this is one fifth. This is minus 0.0. So what types of this one? Yes, transition fits, right? Because this current is crossed.
Yeah.
Right?
Yeah.
So do you know how to write or how to calculate the limits of the clearing or limits of the interference? So the maximum limit of size is here. Here is 50.0. Yes, the minimum is 50.0012, right? So this is maximum is 50.0050. The minimum
50.018.
the 50 is the minimum.
Oh, sorry, minimum is
9.018.
0.0
Yeah.
09.
Right?
Yeah.
Understand it? Everyone? No? Okay. So you can see this or to watch or see this figure, and you can to calculate the maximum limit of the size, a minimum limit of the size for the hole. The maximum is this is the basic line here. This is the minimum, the up deviation. The up deviation plus the basic line, so is the limit, the maximum limit of the size. So this is the maximum limit size is 50.025. You understand? Yes. You understand, everyone?
Someone is
Don't want ask me.
no, that's good.
Wait. You understand me?
Yeah.
The maximum is the up deviation. The up deviation is the maximum. Maximum deviation. So it means that the basic line plus up deviation. Understand? Do you answer the question?
From basic line to observation.
No. You are looking for maximum limit size, minimum limit size. So it's size. This is the limit. This is the size. This is the basic
size.
So the actual size for the highest is 50 plus 0.025. Which means the highest you can go for the whole is 50.025. And the lowest you can go is 50.012. So just addition, you understand? And then when it comes to the shaft, because this is class, so you add the highest you can go for the shaft is 50.0125. And the lowest you can go, this is minus, so you have to subtract. So you get 49.9. Fantastic.
Understand?
Yeah.
Okay. Thank you. Explain it again. And the limit of the clearance, right? So the variation of the feature. And what the class of the feature is, that is the transition feature. Understand? Transition feature, no problem.
So this would be interference.
Huh?
Interference.
Interference. So the limit of the clearance of the interference, it means that you should to distinguish what kind of the type, it's the figure type, and then to calculate the limits of the clearance or the limits of the interference. For the transition feature, they have the clearance and also the interference, right? Okay. So this is the transition feature, right? So the maximum clearance it means maximum clearance is X, right?
Yeah.
So is X is we use the maximum hole to ascend the minimum shaft. So what is the maximum hole? Right? So is 50 to balance to fit the
50 minus plus.
No.
Yeah, it should be
the
plus.
whole to balance the
Minimum.
minimum
0.018.
39, right?
8. What's 8.8?
And in 3, right?
What's 8.8?
Right?
Oh.
Is this one?
What's 9? 8 rather.
9 is 2.
That is this minus this.
Yeah.
So yeah. So
Oh,
zero.
oh, zero.
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 Zero. No.
Nine.
Why is zero?
Nine. That's the
So that is the maximum
maximum variation of the fit.
clearance, right?
Yeah.
Maximum clearance. You use the biggest of the maximum hole to balance the minimum shaft. Minimum shaft is here, right? So this is the clearance, the maximum clearance, right? And also we use the ES balance. E, yeah, it's the same. Because this one is the ES add D, right?
Yeah.
Balance. You have I add T, right? Yes. D. Yes. Right? So D is the same. So the ES balance ES. So this is easier to calculate. So that this word is easier to understand.
Yeah.
Yes. Understand?
Yeah.
Okay, continue. And the what? The interference. Interference is mean that Smaller?
Smaller hole to assemble the bigger shaft.
Yes. The small hole is here, right? So it's EI minus the big shaft is ES.
No, but also
It's the same, right?
same. Yeah, it's using at the basic.
Understand? So, yeah, there is other tolerance there. So that everything is finished already. You just understand it.
Yeah.
Just understand the term. The terms. I explained the term, and then all the kind of the feet. Oh, sorry.
No problem.
Continue. Give your question, and you can to figure the figure, draw the figure, the tolerance figure, and to distinguish all the kinds of feet. Okay.
That's that.
So this is the answer. The answer, you can to calculate that. And this is to this example, exercise. Go back, this one.
Someone sending Chinese machine.
Give your exercise, and then you can to understand how to calculate this one. The exercise, the book 2-3, this one, okay?
Homework. Or next class.
Now the homework, just to exercise in here. And then the homework, okay? There's so much.
Oh,
This one not homework, this one is homework, okay? So give this one. And do it in the class. If you have some question, you can ask me. This one. Give out your letters.
We have to
To almost.
I think you should have more.
Here. Sorry. This is the homework. This is just the exercise. You do it here, yes. You did it here because I already figured this one. I drew the figure, and you can follow me and draw the figure and to not homework. You can do it. You can know how to do it. It's very quickly, and they are already finished the homework before.
That's not right. You have to go home and then solve.
It's okay. Not very so many, so much. Just one, just the table, and then this table, 2 tables, not so much. And this you do it here. Draw like me draw the figure, and then to calculate the limit of the clearance. Do you stand and think about the answer question? Huh? This one. Minimum. Yeah. from here to there. Is it hard? Is it difficult?
No, I think so.
Yeah.
Wow.
So very
So many, so many.
the class. Not covered in this class.
Yeah, now.
I just to read the book here and I see it. I think you need this.
What the limits are. What the limits are. Will be up. For everything are the limit.
Yes.
Say calculate the limit of the
Currently, the derivation or the derivation. Question here.
Yeah, the question, the limits. Yeah, the question.
Yeah.
You don't need to problem.
It is calculates also. Of course, it is calculates the limits of the stuff. So.
Oh, yeah. There. Plus.
Ready, finish that?
Can you try?
Right. What is the this is the yes. This pentagram, see EI in there, right? There in here, right? There, there in here, here. Oh, right? This is the zero. Yeah, zero, zero, one is here, right? Oh, here. depend on you, the this depend on you. That is zero. Right? This is so this is after the EI. What is the EI?
It's 19.8.
19.8.
This is not EI. This is the limit. So
Okay, so that's minus 9. Actually, so please reference 0.
so you
Zero, one, one.
you didn't calculate the and then you figure the this one.
Actually, last week.
Yeah. So this is EI, and then you write it.
After you get seen.
Distinguish all the types of the repeats. So the figure, you figure the tolerance.
Right.
In the figure, the tolerance figure, tolerance diagram. Diagram. You finish this. That and this is the very
Zero, one, two, three.
it's five. It's five. The direction. And this is the
It's a
zero. It's the right. Yeah. And yeah, zero. No, that is the maximum.
Yeah.
So you can calculate the maximum. The least clearly of each period. That. Limit is a clear or it's period.
Oh, yeah. Okay. Thanks. Invisible.
Okay, and it's same person, same problem with the thing.
Wow.
Zero, it's zero. The EI, zero is here. Zero is here, right? This is zero. Right? So you look around here, you get this is the limit here, here. Yeah. That's the EI is the low deviation, right? The deviation is here, right? Deviation is ES zero, zero, one. The is here. Right, it depends on you, the length depends on you. This is zero.
Oh, that patient is supposed
Yeah,
to.
the start point, start line, here, right? So this is. Zero, zero, one. This word, this.
We already made.
No, this is not the, I mean, this is very, the standard figure. The standard diagram. This is yes, yeah. This is the maximum image size, right? Maximum size, maximum size. 20, 0, 1, maximum size, this is minimum size, 20. The EI equals to what? Negative 1, 0, 1, right? This is here. So ES is the ES is the 0, 0 is the factor. 0, the ES is here, right? This is 0, this is 0, ES is here, right? This is yes, that is
Actually.
right.
No,
Translation.
Doing the
How we put this in.
Twenty, 40, 102, 41, 40. This one is interference. It means that the bigger shaft. Interference, bigger shaft. Bigger shaft is bigger is the shaft. Bigger is the option is BI. So that is the size of the shaft.
That is 7 whole minus.
Sorry. Yeah. You are giving me that the whole, yeah. The back, the smaller hole.
Yeah.
Smaller hole.
Is 0.
Yeah. Yeah. Yeah, before you understand it, easier. And this is what's there. There is here. Right? It means that the starts with this. Yeah. Yeah. Now this one. Number 21. And the interference. The limit of interference of interference. Consider the limit of the clearance into the interference.
What? 0.
Just
Yeah.
you The first question is which page? Another question.
You mean that there's no maximum, right? This is the maximum. ES. No.
Yeah, after class.
So,
Susan,
We will draw for the
you see this bar? This is like your normal Cartesian plane. You understand? Now this one. So here is zero. So whatever is up is plus. Whatever is down is minus. So you see the way we draw the Cartesian plane. This one, this is not part of the material. Yeah. So when they tell you the basic size is the basic size here is 20. So we write the 20 here, so we don't forget. But this is the actual size, the diameter. You understand? Yes, I'm coming here. I'm coming to the limit. Yeah. I'm coming. That's what, because if you don't understand this, you don't understand what the table is talking about. Yeah. So whatever is down is minus, whatever is up is plus. So now the question said that the maximum limit of the hole. So the hole, you draw the hole on the left, and you draw the hole on the shaft on the right. Because that's how we have to draw. Yeah. It depends on you, wherever you want to draw. No, not up or down, left or right. We are writing the hole to the left, not up or down. You understand? The hole is to the left, the shaft is to the right. Yeah. So the shaft, the hole is here to the left, the shaft is to the right. When it comes to top or down, it depends on whether it's positive or negative. Yeah. So if you have the maximum of the hole is what? Is 20, and the minimum of the hole is what? 19.9. This is the minimum of the hole. 20. So if the minimum of the hole is 20, remember I told you from here to here is 20, right? So the minimum of the hole is 20. What is the limit of the hole? The difference. 20 minus 20 is 0. So it will be on the line. It will be on the line.
I don't know, they have some question online students or not. No question, online students?
Yeah, you understand? So the base of the hole will be on the line because it's 0. You understand? They say the upper limit of the hole is what? 20.021. So the upper limit should
Do you
be
have some questions, online students?
021. But we don't want the 20, right? It's only the limit. So 20.021. Yeah. So here's
No, last.
the volume.
Okay, no, I will send the PPT here.
Yeah, sure.
Bye, bye. Hello, can you type the questions?
So these are the limits, actually. Not the right hand. Oh,
Send the PPT on our WeChat group, Lars.
Okay, I want to share the PPT to the group.
yeah.
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 Your monitor knows the content very well. If you have some questions, you can ask. You can ask the monitor. There.
Yes,
There. Yeah. Okay. Hello.
Your mic is
I think the next chapter, not next chapter, next class, that is a little more difficult than this class. Okay.
If you can send us a PPT of next class, maybe we will see review before
Review so that
maybe we'll be
Okay. Before you mean that, I will review your. Okay.
and if you can send it as
class.
Yeah, class over.
Thank you, Lao. Fantastic.
Okay, so why do it just like
Jadian Lao.
TX is the same tolerance. This is the this is a clearance.
What
Is
just
the
happened to this class?
Innocent Bob. How are you, bro?
the minimum clearance to maximum clearance.
But I mean, because the value of the clearance and the interference and the TF all are the same.
We wait till you done.
Yes.
TF with the clearance to the interference.
Clearance to interference and to interference to variation of clearance. It's all the same value.